Well, this is to you all here. Dear students, in this video we are going to learn about the modern atomic model, of course proposed by Schrödinger. The Schrödinger was the scientist who first of all taken the electron not as particle. Still the electrons were taken as particle. He didn't do that. Instead, he told that electrons are complete wave. This assumption made the things different. Because suppose electron is a particle, then it will be moving in this way. That is the path of the electron traveling. That is, of course, a straight line or a circular one, anything. But if it becomes wave, it is moving in just like that. Here it is the amplitude of the wave represented as psi, and this is the complete 3D area where the finding probability of electron is there. The finding probability of electron phi, of course, is equals to psi square. Then electrons were supposed to having the wave nature, and he proposed the concept of orbital. What is orbital? Orbital is a 3D space around the nucleus where finding probability of electron is maximum. Then students, remember, this is the nucleus. Then the finding probability of electron sometimes maybe here, sometimes maybe here. It is just like that. Every dot is representing the finding probability of electron. But now you are able to see that this is the 3D area where finding probability of electron is maximum. Maximum numbers of dots are here. Then this 3D area will be called as orbital. Then just like you can assume, orbital is just like clouds. Similarly, just like clouds are just not having any kind of shape, orbitals are also do not have. But it is the 3D area where the finding probability of electron is maximum. And in one orbital, there is always two electrons if they are spinning in opposite direction. That is also a crucial postulate of this model, that an orbital can have maximum two electrons which are spinning in opposite direction. If one electron is spinning in clockwise direction, then definitely the second electron is spinning in anti-clockwise direction. These two electrons can be there in an orbital. Then what he proposed? According to Schrödinger, orbitals are getting merged together in order to produce subcells. Subcells getting merged together in order to produce cell. Of course, what you are having, I am just going for. Look at this. According to him, electrons are present in cell. Cell in turn is made up of subcells which are of four types S, P, D and F. Subcells in turn are made up of orbitals, and of course one orbital is having two electrons, so you can have the total number of electrons here. Here it is, we are going. If the first cell we are talking about, that is the K cell, then the total number of subcells present in a cell will always be equals to its principal quantum number. For the first cell, the principal quantum number is 1. For the second cell, the principal quantum number is 2. Similarly, it is going. It means in the K cell, only one subcell can be there, and the first is always there, S subcell. S subcell is having only one orbital, and that is also S orbital. And of course, one orbital can have two electrons, then the total number of electrons in the very first cell is always equals to 2. If you are talking about the second cell, that is L, so this is the second cell, that's why it will be having two subcells. Now you have to place here two subcells, the lower energy subcells are always preceding each other, S and P subcells are there. S subcell is having one orbital, but the P subcell is having three orbitals. The names are Px, Py, Pz. Of course, here you go. 3 plus 1, 4 orbitals are there. That's why the total number of electron 4 multiplied by 2 will be equals to 8. The third cell, it is M. Then definitely it will have the 3 subcells S, P and D. S is having 1 subcell, P is having the orbital, P is having 3 orbitals, and here it is D, which is having 5 orbitals. dxy, dyz, dxz, dx square minus y square and dz square. So you can count 5 d orbitals, 3 p orbitals and 1 s orbital. Total 5 plus 3, 8 plus 1, 9. 9 multiplied by 2 will be equals to 18. Then the fourth cell, N. This will have all the 4 subsets. These are S, P, D and F. S will have 1 orbital. P, as you are seeing here, 3 orbitals. D is having 5 orbitals. And F, of course, is having 7 orbitals total. If we are counting these in total, 7 plus 5, 12 plus 3, 15 plus 1, 16. Then 16 multiplied by 2 will be equals to 32. Dear students, now you are able to see here what you have studied in the previous classes, that the first cell can have maximum 2 electrons, second cell can have maximum 8 electrons, third cell can have maximum 18 electrons, fourth cell can have maximum 32 electrons. That is a simple brief. This is a brief account of the modern periodic table. If you are having a concept like that, then you will never fail to study to understand the basics of modern periodic table. Modern atomic model. One more thing I am interested to discuss here, dear students. This is S subcell, and since S subcell is having 1 orbital and 1 orbital can have maximum 2 electrons. I am just going to erase this. Look at this. What I am trying to discuss here. Now, if I am just representing the subcells, S subcell is there having 1 orbital and 1 orbital can have 2 electrons, thus why it has been represented as S2. P subcell is having 3 orbitals multiplied by 2, it can have maximum 6 electrons, thus it has been represented as P6. D subcell is having 5 orbitals, 2 electrons each, thus it can carry maximum 10 electrons and the representation is D10. F subcell is having 7 orbitals, each can carry 2 electrons and the representation is F14. So this is a simple representation of the subcells. S subcell as S2, P subcell as P6, D subcell as D10 and F subcell as F14. This is about the modern atomic model. Thank you.